Good afternoon, everyone. In this video, I'm going to explain the machine learning techniques experiment for the single layer perceptron. The aim of this experiment is to develop a single layer perceptron classification model and evaluate the performance of the model using metrics like accuracy, precision, recall, F1 score, and confusion metrics. And the first one is read CSV data into pandas data frame. And what I did is in this step, I imported the required Python libraries and load the penguins dataset using pandas. The dataset is stored in CSV file and converted into a pandas data frame so that it can easily analyze and process the data. And the second one is data pre-processing, handling missing values. In real world data set, some values may be missing. To handle this issue, we perform data pre-processing. Here I replace the missing values with the mean of that column, which is a common technique called mean imputation. And the third one is choose independent and dependent variables. And in this, independent variables are used as input features to predict the output. Here I use for penguin measurements as input features, and the species of the penguins is in the target variable. And the fourth one is standardize the input features. Why this is needed means different features may have different ranges. And for example, for modulus in thousands, build at the small values. Standardize helps a model learn better. Future scaling ensures that all input features are in the same range. This improves the training performance of machine learning models. And the fifth one is split data set into training and testing. And this splitted the data into training and testing sets so that the model can glean from one portion of the data and be evaluated on unseen data. And the sixth one is assign model parameters. Assign model parameters. In this step, I initialize the perceptron parameters such as learning rate, number of iterations, weights, and bias. These parameters are necessary for training the model. And the seventh one is training the perceptron model. And the perceptron formula inputs y is equal to w into x plus b. Weight update rule update is equal to learning rate into actual minus predicted. What happens during training means first we have to compute the prediction, calculate error, update weights, and then store error count. During training, the perceptron calculates predictions for each data point. If the prediction is wrong, the model updates its weights and bias using the perceptron learning rule. And the eighth one is display final weights, meaning each weight represents the importance of the feature in classification. After training the perceptron model, we display the final weights and bias values. These values represent how strongly each feature contributes to predicting the class. And the ninth one is plot iterations versus error. This graph shows how the number of classification errors decreases as the training iterations increase. And the 10th one is predict the class labels. What happens when some model predicts a class label for a test data using the trained weights. After training the model, we use a learned weights and bias to predict class labels for the test data set. And 11th one is evaluate the model performance, confusion matrix. Actually, for true negative means predicted 12, false positive means 0, false negative also 0, true positive means 8. And finally, we evaluate the performance of the perceptron model using metrics such as accuracy, precision, recall, and FM score. The confusion matrix also shows the correct and incorrect predictions made by the model. That's all. Thank you.